Iftika, am I audible?
Yes, yes, we can hear
All
you.
right. So a very good morning to all. I am Mohit, and today I'll be talking about one of the very relevant topic in the context of developing economies, which is agriculture. Specifically, I'll talk about the role of subsidy and contract farming. All right. So let me start the discussion with a very brief introduction to agriculture supply chain and the challenges associated with it. So agriculture supply chain could be categorized into three broad stages. So we have planting stage, maturity and harvesting stage, and selling stage. In planting stage, farmers determine which crop would yield them the maximum profit and they act on it. So whatever quantity a farmer sows in the planting stage, they may not get the same proportion of output in the selling stage because of various factors like amount of rainfall received, the soil quality of the land, the agriculture practice adopted by the farmers, seed quality, so on and so forth. So in literature, in agriculture operation literature, this phenomena is called yield uncertainty. That is, whatever quantity you sow, you are not getting same proportion of output. In fact, the nature decides the yield of the crop. So whatever quantity you are getting at selling stage, you sell it in a wholesale market. Other names are mandi. So these are sold by farmers directly into the mandi. So in fact, there is no denying that in the context of developing economies, agriculture sector plays a key role in the economic development of the country. However, the issue is farmers, they are not willing to carry on farming activities. Why? Low return on the investment could be one of the prime reason why farmers are not willing to carry out farming activities. So to solve this, Indian government in 2020 came up with Indian Agricultural Act. So the objective for the government was to improve the income of the farmers, to transform the agricultural landscape in developing economies like India, and to enhance the welfare of the society. However, farmers, they took it differently. They thought their income would decline and private players, if allowed, they'll try to exploit these farmers. Therefore, motivated by this context, we are trying to answer whether farmers will benefit from a firm's entry and how should a government design input cost subsidy in the presence of contract farming? And third, which crop types would be eligible for contract farming? In meanwhile, we are also extending the extent body of literature. So our work is going to the first work, so which incorporates contract farming with endogenous cost subsidy in the context of two different crops in presence of smallholder farmers. So let us try to look at the model. I mean, these are some of the notations that I have used in the modeling. And we have used two crops. Crop one is a staple crop, which is used for food consumption. Example could be wheat and rice. Government is actually assisting these farmers by subsidizing their inputs. And crop two is a specialized crop for which you require firm intervention. So farmers may not be able to sow the crop without help of you know firms. So firms are actually assisting these farmers and they're sharing technology, efficient farming practices, weather forecast, when to sow, and so on. So this is we call a contract kind of farming. Farmer that we are considering in our model are infinitesimally small. Why? Because in the context of developing economies, 85% of the farmers they are smallholders. And what do I mean by smallholders? The land holding of a farmer is very small. So their production quantity would not influence the market price. However, the total production quantity of all the farmers would influence. So this is the notion of infinitesimally small. They are also considered to be a risk neutral in our model. And the demand for two crops are these two inverse demand equations that we have used. So we have considered three players. So we have farmers, a processor, which is also private firm, and government. So objective for a farmer is, to maximize their profit. So either they'll sow crop one, or they'll sow crop two, or the third option, they may not sow any crop because it is unprofitable for them. Why? Because the cost would be very high. Second, for a processor, their objective is to maximize their profit because they are doing contract with the farmers. So they'll try to keep their decision variable W such that their profit is very high. And the government objective is to maximize the social welfare, which comprises of farmer surplus, consumer surplus, profit of a processor, minus government expenditure, minus shortage cost. So what is the shortage cost? Shortage cost is cost that a government has to incur, because if you look at crop one is a food staple crop, which is required for food consumption. If there is a crop shortages, the government will have to incur cost, because if there is no crop, so there will be issue related to malnutrition and hunger. And therefore, we have incorporated shortage cost as well. So government decision variable is subsidy. What subsidy they should give so that a social welfare is maximized. So in this context, we'll try to answer our three research questions. So these are, the sequence of events at t equal to 0, which is before the sowing season or at the start of the sowing season, government announces subsidy, which is beta, and a firm announces their wholesale price W for the contract farming. After knowing the subsidy and the wholesale price, farmers decide whether to sow crop one or crop two, or do not sow any crop. Once they have sowed the crop, the nature will decide the yield of the crop, and after the realization of the yield, the crops are harvested and sold in the different markets. So these two crops have different market. One is sold in the wholesale market, and the contract farming crop is being sold directly to the private firm, and the private firm will process it and then sell it to customers. So now let us look at some of the interesting results that we have found out. So first, wait a minute. All right. So let us try to look at the results. So we have considered three cases. So case one is when we have no government and no contract farming. Under this context, we'll try to understand how yield uncertainty and average yield is impacting different metrics. What are the different metrics? Farmer surplus, consumer surplus, crop shortages, and social welfare. So we find that if the yield uncertainty is very high, that is theta is very high, then what will happen? As theta rises, more and more farmers, they are actually abstaining from cultivation. Why? Because their profitability reduces as yield uncertainty rises, which leads to a larger fraction of land which is idle, which is not under cultivation, which is not good for the society, because if lower number of farmers are cultivating the crop, then there will be crop shortages. So if there is a crop shortages, so the social welfare will reduce. On the other hand, if my average yield rises, then your consumers will benefit, shortage cost would decrease, and social welfare will improve. However, these all come at a cost of reducing farmer surplus. Why? Because if your yield is very high, the prices of your crop will go down, will substantially go down. And in that condition, the total farmer surplus will go down. But consumers will enjoy low prices. And essentially, society will benefit out of it. So with this lemma one, we argue that low yield with high yield uncertainty is actually causing crop shortages and hurts society. Therefore, government should come up, they should actually try to assist the farmers, because wheat and rice, these are staple crop. So from food security, government should incentivize farmers to sow the crop when your yield is low and your uncertainty is very high. And therefore, we introduce government as another player in case two, which is represented by case 2G, that is presence of government subsidy, but absence of contract farming. In this, we find out indeed government is giving positive subsidy which is a function of shortest cost and average yield. So let us suppose if your shortest cost rises, so what will happen? Government will try to increase their subsidy, which is intuitive, right? If shortest cost is rising, you should give higher subsidy so that more number of farmers are producing the crop, so that you have larger crop production in equilibrium. And in fact, we find that figure 2 illustrates that now in equilibrium, your tau z, which is a function of beta star g, is higher compared to the case when no government was there. So which implies in equilibrium now a larger quantity of crops are produced, which is good for the society. In fact, for very high shortest cost, government would give subsidy, which is represented by beta hat z, such that every farmer is actually cultivating the crop. However, if your shortest cost is not very high, then there will exist some idle agricultural land. Further, we also try to look at the impact of yield uncertainty and average yield in the case when only government is there. But we find that the overall structure of the results remain the same. That is, with increase of yield uncertainty, farmers are abstaining. And with increase of average yield, crop prices reduces, consumers benefit, shortest cost decreases, and social surplus improves. But this comes at a cost of farmer surplus. So overall structure remains the same, but the important point that I want to argue here is that the farmers and consumers, they are now become more tolerant to average yield and its uncertainty because of government intervention. So, but still low average yield coupled with high yield variability is actually hurting the society and is actually causing crop shortages. So what can be done next? So the government subsidies alone cannot fully safeguard farmers' interest and enhance the social surplus. This raises the following question: is there any other mechanism that can be used along with government subsidies to improve farmer surplus and social value? In fact, Government of India in 2022 they came up with Indian Agriculture Act to say let us try to bring in private players who would try to help the farmers in farming practices. So next, we'll try to introduce government subsidy along with contract farming, which we represent as case PG. Here we find that if the wholesale price that firm is offering to a farmer, if it is low, no farmer is ready to sow crop to. However, if your wholesale price is not low, both the crops will be shown in equilibrium. And this line represents, let's say, from 0 to tau 3, this is the fraction of farmers who are going to grow crop 1. And from tau 3 to mean of 1 comma tau 2 are those fractions who are going to grow crop 2 in equilibrium. So having known what are my fraction of farmers who are going to cultivate crop 1 and crop 2, this decision will be used by the processor and the government to determine the equilibrium wholesale price and subsidy. So let us try to look at, first we'll try to look at the best response of a processor. Here we find that if the market potential of crop 2 is a contracted crop. So if the market potential is low, we find that indeed, if you are, even if your market potential is low or market potential is high, as beta increases, so your x-axis is beta, which is the subsidy, as beta increases, your W, which is the wholesale price, this increases, right? But the contrast that I want to emphasize on is if your market potential is less than a particular threshold, let's say it's low, then you start from between this red line and green line. What is this red line and green line? So green line is the minimum wholesale price that you should offer. If you are offering below the green line, nobody is ready to cultivate crop 2. And what is this red line? Red line is the maximum wholesale price that you should offer so that everyone is cultivating crop. So you should not offer beyond this red line. So you're operating somewhere in between red line and green line when your market potential is low. However, when the market potential is high, so you operate, so for a low subsidy, you're operating at red line, right? That is, if your market potential is very high, you're giving such a high wholesale price, which incentivizes every farmer to cultivate the contract farming crop, which is crop 2. However, if government becomes aggressive, let's say they are increasing the subsidy, then now my farmers are actually producing both the crops. And if my subsidy is very high, You are touching the green line. That is, nobody is going to show the crop to because your subsidy is very high. Contract farming is not profitable. Same for gamma low. So having known the best response of a processor, let us try to look at the best response of the government. Before we look at the best response of the government, what I did, I tried to plot the farmer surplus at the best response of the processor for varying level of subsidy. And this gives us a hint that if your shortest cost is low, your farmer surplus in the case of PG, which is case 3, that is processor is there and government is there, it is always higher irrespective of subsidy given by the government. So even if a government is giving zero subsidy, your farmer surplus is always well off compared to G case and B case. But when farmer surplus is high, we find that, okay, there exists a range of subsidy for which farmers may be worse off. And this is the interesting thing, right? So this gives us some understanding, okay, there can be some cases where farmers can become worse off. So if you don't want your farmers to be worse off, you should give a threshold of beta bar, which is in this case, maybe is 0.2. So you should give this, but does whether this will happen in equilibrium or not, this is the next question, right? So now what we'll do, we'll try to evaluate the best response, we'll compute the best response of the government, and we'll try to find out the equilibrium. What is my equilibrium subsidy and equilibrium wholesale price? And then we'll substitute the equilibrium wholesale price and the subsidy to determine what is my different matrices, right? So let us try to look at when we plug in the best response of the government and the best response of a processor, and then we compute what is the equilibrium, subsidy, and wholesale price. So we find that, okay, for a moderate level of market potential, your farmer surplus is actually lower compared to G case, which is the case when only government is there. So this is detrimental for the farmers. And indeed, farmers' concern that their income would deteriorate is partially correct. But the government is also correct. So, correct in the sense that, okay, if I operate in this zone, which is gamma is high or gamma is low, we can find that, okay, with firm's entry, my farmer surplus are better off. But you cannot, disapprove the farmer's concern that their income would decline. So what can government do? So either they should allow contract farming for significantly different market potential of crop, either in this zone or in this zone. However, if you are operating in this zone, then you'll have to, give a minimum threshold of subsidy that is being represented by proposition 2, that is beta bar. So you should at least promise the farmers that, okay, if I give you at least beta bar, then your profit would improve. And this was missing in the farm bill that the government presented to the farmers. However, if you look at, the social welfare, this is always improving, irrespective of irrespective of gamma values. So for any gamma values, your social welfare is always improving. So that was the indeed interesting point that we came up with. So our work is, helping these three stakeholders, farmers. To farmers, we are helping them in their sowing decision, whether to sow crop 1 or sow crop 2, or whether to refrain from sowing. And to firm, we are suggesting them what should be the wholesale price they should charge, depending on the varying level of subsidy. And to government, we are suggesting whether they should give subsidy or not, to which type of crops they should give subsidy, and what should be the minimum threshold of subsidy so that farmers are always well off. So these are our answers to the following research question. Will farmers always benefit from a firm's entry? Indeed, no. We showed that, okay, farmers can be worse off if the market potential of crop 2 is moderate. So therefore, a careful design of input subsidies can safeguard farmers. So what is the minimum threshold value of subsidy, which is beta bar? So if you give beta bar, farmers are always protected. Now, the second answer to our research question 2, how does the government design input cost subsidy in the presence of contract farming? So it depends on the objective. If you want to protect farmer surplus, you should spend your max of beta bar and beta star unconstrained. And if you want to maximize your social welfare, spend beta star unconstrained. answer to the research question three, which crops should be eligible for subsidies and contract farming? So we showed to a graph that high and low market potential of crop two. Under this situation, farmers are always well off. And if you want to, allow contract farming for moderate, then farmer surplus would decline. So these are some of the limitations I have worked. So we assume the farmers to be risk neutral. So, but there are cases where farmers show a behavior of risk aversion. We have not captured that. And the type of subsidy that we have incorporated in our model is a flat subsidy. So, there could be potential avenues for, cost proportional multiplicative subsidies. And we have not considered different other intervention mechanisms that the government uses in the context of developed economies, like minimum support price, where government procures crops like wheat and rice. So thank you. That's all from my side.